In our next problem, we have a formula. A formula is a literal equation where each variable stands for something. So on this question, it says a car's fuel economy, E, in miles per gallon, is given by the formula E equals M over G. M is the number of miles driven. G is the number of gallons of fuel used. I want to solve this formula for M. So I'm going to start here. I'm just going to copy down my problem. E equals M over G. Well, division, the opposite of dividing to get M by itself is multiplying. So I'm going to multiply both sides by G. So on the right-hand side, notice here G is reduced. I'm going to write my E first just because I like to write it that way. Although you could write G then E. I'm going to write EG equals M. And you just solve this variable, this formula for M. Now we're going to use that on example 4. On example 4 it says if Quanta's car has an average fuel consumption of 30 miles per gallon and she used 9.5 gallons, how far did she drive? Well, to find how far she drove, that's using our formula. M equals E times G. This case, we know E is miles per gallon, so that's 30 miles per gallon. So this is E. So I'm going to say 30 times, what's G? Well, G is 9.5 gallons. So 30 times 9.5. So then 30 times 9 is 270. Half of 30 is 15, so you get 285. And this is a word problem, so don't forget your unit. M is measured in miles. That's what we're going to do. Now, the second part of our lesson, we're going to be looking at dimensional analysis. And a dimensional analysis is just converting units. That's all it is. When we do dimensional analysis, we don't care if we multiply or divide. We're just going to always multiply by 1. And then we're going to convert our units. So, in chemistry, they call this stoichiometry. It's the same thing. When they say dimensional analysis or stoichiometry, you're just making sure the units line up. So we look at example 5 here. So the average weight of a chimpanzee at a zoo is 52 kilograms. If 1 gram is 0.0353 ounces, use dimensional analysis to find the average weight of a chimpanzee in pounds. So I'm going to start here. I'm going to start with 53 kilograms. And I want to convert kilograms to pounds. So I'm going to put it over 1, like a fraction. I'm going to change, now in order to change kilograms to pounds, first I have to change kilograms to grams so I can convert it. This is the one you're supposed to know. We should know at this point there are 1,000 grams in 1 kilogram. So what happens here, I make sure my kilogram reduces, so I put 1 kilogram in the denominator. And I have 1,000 grams in the numerator. Notice the reason I do this is because now, sometimes I call this the boom boom method, the kilograms go boom boom. They reduce each other out. So now my answer is going to be in grams. Now I'm going to use what I'm given in the problem, and that in the problem it tells us 1 gram is 0.0353 ounces. So I'm going to change that to ounces. So I want the grams to reduce, so I'm going to put 1 gram in the denominator. I'll put 0.0353 ounces in the numerator. And so once again, notice the grams reduce. So now my answer is in ounces. And then I'm going to change ounces to pounds. So I know in 1 pound, there are 16 ounces. You just make sure your units reduce. And then what we're going to do is we're going to do what it says. We're going to take 53 times 1,000 times 0.0353, and I'll divide by 16 because 16 is in my denominator. So at this point, we're going to use our calculator. Let me see here. Sorry, I got too much stuff open here. Here we go. So we're going to take 53. If it'll opens up for me, there we go. So we take 53 times 1,000 times 0.0353 Come on, not registering. 5.3. Then I'll divide it by 1,000. Where you put, since you're just multiplying, dividing, or divide by 16. Sorry about that. And then I just noticed I don't have my decimal in there. Make sure that decimal gets in there. There we go. And notice you get 1169.3125. Now you don't need 4 decimals. In fact, if we take a look, they rounded to the nearest kilogram, so we're just going to round to the nearest pound. So we're going to say about 1,169 pounds. Well, you know what? 0.03. Sorry about that. There we go. Because that didn't make sense, did it? So about 117 pounds. So we're going to say, I like to put my wavy equal sign, because that means approximately. We're going to say about 117 pounds. And we'll just round it to the nearest pound. You could have rounded to the nearest tenth, and that still would have been correct. You could say 116.9 pounds. But if you get anything beyond that, it's getting kind of useless because we didn't measure it that closely.